Good morning, good afternoon, or good evening, wherever you are. I'd like to thank you for sitting in on this session. During this session, we're going to go through some AIX performance tuning tips. I'm Jackie Lynch, and I work with Flagship Solutions Group as a solutions architect, but I've been living and breathing AIX performance for very, very many years. So I have structured this presentation to basically cover the top 10 tips that I think are important for AIX performance. I'm not going to read these to you. Instead, we'll go through them as we go through each of the slides. So the first one is stay current. And when you're talking about staying current, you also can't forget your NIM server. The NIM server needs to be the most current of all of your LPARs. In order to stay current, there is a patch order that you typically should follow. It should always start with reading all the readmes for any upgrades, fixes, etc. I normally do my HMC first, and then I'll do my server firmware. I'll do my NIM server. I try to keep my NIM server as a standalone system, but it needs to be at the highest level. I also then do any IO firmware. The next step is all my VIO servers and any IO firmware for firmware that is associated with them. And finally, I do all my LPARs, AIX, IBMI, Linux. I document everything. In fact, prior to doing any kind of an upgrade, I actually pre-document every step that I'm going to follow, and then I tweak the documentation as I go. The one thing that I sometimes change is that the firmware is sometimes done last, and the only reason for that is going to be maintenance windows. But again, I always check that everything that I'm doing at each step goes together seamlessly. And in order to check those prereqs, I use Flirt or Flirt Lite, and the links on this page are a number of links that you'll find useful. They show you things like the VIOS to NIM master mapping, the VIO server security tables, and the Flirt Lite homepages, etc. When staying current with AIX, one of the things I remind people is that it's not just your AIX LPAR. It's your HMC, your server, the IO firmware, your VIO server updates. All of these can cause performance problems that you may not find when you're looking at your AIX systems. And below I have some links that you should find useful. The next tip is in putting on hypers and other fixes. So as an example, Java, SSH, and SSL should be kept current. That's both for security reasons and performance reasons. And you download Java from Fix Central, SSH and SSL are downloaded from the web download pack. And I have a list down here of the latest levels as of August 15th. By the time you do this, they may change, so you should check them all. eFixes and iFixes are security patches or pervasive fixes that need to go on that have not been integrated into a service pack or a technology level. And we use the fix level recommendation tool vulnerability checker, also known as FlirtVC, to determine what fixes are needed. After you run it, it will give you a file that you can look at that actually shows you all of the links and everything to the various patches, and you can then go and download them. eFixes and iFixes are downloaded using FTP or HTTP, and SSH, SSL, and Java are downloaded from various sites on IBM. For the eFixes and iFixes, you use eManager to actually install them. This is also the one exception for a VIO server where you install software without using Update iOS. If you run eManager and there's no fixes listed, you probably have some security holes and should consider patching. So what do you do if your upgrade goes south? This is very important to know, is what to do when you have a problem. And you should know how to run a perf PMR. You should know how to run a snap, and you should know how to open a support ticket. IBM is going to expect you to do that, and that's actually what they will ask you to do. So you should actually have those codes downloaded in advance and know how to get them. If I'm doing a major upgrade, I will quite often run a perf PMR and a snap prior to doing the upgrade, and then another one afterwards in case I have problems. And of course, you'll see at the bottom I mentioned having everything pre-documented so that it's very easy for you to provide any information that they actually request. Our third tip involves keeping things simple and keeping them consistent. So in general, you want to keep things simple. There are some very, very cool, complicated things that you can do, but by taking advantage of those, you sometimes make it very, very difficult to debug things. I also mentioned consistency. I try to set up all my LPARs at a basic level exactly the same, so that if I have a problem on one and I figure out what it is, I can then resolve it on all of the others, hopefully before it occurs. Now the LMB is also known as the region option, and it's basically the minimum size for a memory block. By default, on a lot of systems, it's 256 meg. You need to make sure when you set up a server that it is the same on all of them if you ever want to use LPM. I also use hot pluggable adapters rather than built-in ones. It's much easier for maintenance. It means you can actually change out an adapter without taking an outage usually. And it's very important that you set up all adapters as desired, not as required. The problem with required is that you then can't take advantage of hot plug and you also can't LPM. And by default, it will quite often set them up as required, so you will probably need to change that in the profiles. I also recommend not mixing multipath drivers on HBAs. If you have two different disk subsystems, try to put them on different HBAs or at least different HBA ports. I also take advantage of the HMC scanner tool and sysplan, and I take copies of them before and after I make any changes. And then the other thing is you need to get maintenance windows at least once a year, preferably twice a year. That's for your HMC, for your servers, for your firmware, everything. And I know it's difficult to get them, but without those maintenance windows, you run the risk of being very, very behind, and that is going to cause you a problem with IBM. And some additional tips to keep you out of trouble. If you're using internal disks, then you do need to mirror root-vg and you need to mirror any page spaces that are on those internal disks. If you're on the SAN, you do not need to do that. I always have a spare disk in my LPAR that I use for cloning prior to updates. In my VIO servers, I'll have a spare disk. In my client LPARs, I also have a spare disk. And I use Alt Disk Copy to take a clone before I do any updating. I also keep my root-vg very, very clean. If I want to add user file systems or application file systems, they never go in root-vg. That way it's quick to back up, quick to restore, and quick to do an Alt Disk Copy. And even though I can get by with just 30 gig in root-vg, I always give about 100 to 150 gig to my root-vg so that I can have a page space in there. You should also check your page spaces. By default, sometimes it puts two page spaces on the same LUN. That's a problem for performance. And of course, you need to add logging and you need to set up your dump devices. And then the items that I have in red are very important. You need to check your error logs. Many performance problems can be solved just by reading those error logs. You also need to make sure that your LPARs and your VIO servers are not running at 100% entitlement all the time. If they are doing that, it's going to affect your network and other performance. And of course, you need to take backups. That's not so much a performance thing as a recovery thing. And when I'm talking about backups, I'm talking about make-sysb images that you can use what we call a bare metal restore, which is basically restoring the LPAR so it can boot. This is separate to your typical AIX data updates. So you need to make sure that those make-sysbs are occurring for all your AIX LPARs and your VIO servers, and that they're occurring to a place where they can be restored from. So if you're using your NIM server, it must be at the highest level of every LPAR and VIO. And our fourth tip involves taking documentation. And people ask, well, what does documentation have to do with performance? It's very, very difficult to diagnose a performance problem if you actually have no idea how your LPARs are set up or how the adapters are allocated, what standards you used or any of that stuff. So I actually have a full set of documentation that I do. I have some pretty complicated spreadsheets, but at a minimum, I use the HMC scanner to pull reports. And in that documentation, you can track versions of the operating system and so on, and you're going to find that it's actually very, very helpful when you do have a problem. And I mentioned backups, and I'm just going to touch on them again briefly, but this is your fifth tip. Whenever I'm making changes, I use Alt Disk Copy before I make the change. So if I have a mirrored root VG, I will unmirror it, but I'll basically take a copy to the second disk so that if I have to recover, I just change the boot list to the new disk and I reboot. That way I don't feel quite so nervous about making performance changes and so on a live system. Now we're going to talk a little more about performance, and one of the things I've noticed is that if someone has a performance problem, they jump into it changing things all over the place. That's not how you work on a performance problem. You need to have a plan. And the starting of the plan is, what exactly are you measuring? There's really two critical measurements in performance. The first is response time, the second is throughput, and they are different. Response time is basically from when I hit the keyboard or request something to when I get my request returned. So think about it in terms of time for a database query, time to get a web page back. It's really about the time that my user is waiting for something. That's what typically generates the telephone calls. Throughput is a different measure. That's a measure of the amount of work that can be accomplished. So transactions per second, file transfer speeds, those kind of things. You need to know the difference, and you need to know for each of your applications what is important, because your performance plan is going to be different depending on which one we're talking about. So what makes a system go slow? There's the obvious things. Not enough CPU, and by that I'm talking about both entitlement and virtual processors. Not enough memory, not enough disk bandwidth. You know, it could be the adapters, it could be the queue depth, it could be the number of disks, it could be the transfer rates. Not enough network bandwidth. Hardware errors, software errors, you go to ERPT to find those. What I see a lot of is insufficient CPU entitlement, where people set the entitlement as low as they can and then give it lots of VPs so it can grow and shrink. And the problem with that is there are many things that are actually affected by the entitlement, and one of those is your network performance. It actually scales by entitlement, not by virtual processors. Plus your entitlement is your guarantee, so that is how much you are guaranteed to get whenever you want it. You are not guaranteed that you will be able to grow to those VPs if someone else is using them. Performance can also be impacted by too many or too few VPs. If you have too many VPs, then you're forever turning on and switching around amongst VPs. And then over-allocating CPU pools is another problem, and we will talk about that in a minute. There's the not so obvious, actual tuning parameters within AIX. A bunch of things in Oracle and DB2, how they allocate their SGA and their buffers and so on. Read versus write characteristics. Certain disks are really good for high read ratios, but if you have a high write ratio, those disks are not so useful. Even things like adaptive placement can have an impact because you can overload your buses. One of the things that does cause problems in the power systems is what we call throttling effects. If you have an application that is single-threaded or actually has a single-thread dependency, you need to watch out for those. And then, of course, there's things like application errors and background processes, a whole bunch of people trying to access the same files, shared resources, network buffers. There's a number of different things. And the one thing I do see a lot of is this no cause left to grow beyond entitlement. And basically, if you've back level on your server IO firmware, if you're missing AIX or VIO patch, all of those have the potential to impact your performance, which is one of the reasons why I started out by saying stay current. So step one is take a deep breath and don't panic. And then sit down and come up with a plan. Why are you even doing this? If you're going to put the time into it, you should know why. And then you go through the steps. Write down what the problem is. Take measurements of where you're at. Recreate the problem, analyze the data, document the changes, and make sure that you know what changes have been made. I once worked on a performance problem where nobody had changed anything, but it took a bank down for a week. And it turned out there'd been one tiny change in what they thought was an unrelated area, and it actually was the problem that took everything out. So you need to know all the changes. Group changes together that go together and then go ahead and make them. And then you measure the results, figure out if they actually did what you expected, If not, try to understand why not. If the problem's solved, then you're done. If the problem's not solved, then you go back through the loop. So these are all things that you have to think about, and it looks like common sense, but in an emergency, when you've got 6 vice presidents standing behind you yelling at you to fix it, the first thing that goes out the window is common sense. So it's really important that you have a plan, that you actually publish ahead of time, that when you're working on a performance problem or issue, these are the steps that you're going to follow. And if you can, find a quiet place to work so you can focus. There's nothing worse than trying to work on a critical problem and you can't even concentrate. So if it's a really major problem and they're insisting on bridge calls, have one person on the team whose job it is to go and sit on those bridge calls and report back on the status. And then the last thing is to make sure everybody understands that tuning is iterative. You may not get it right the first time. You might make it worse, you might make it better, but it's one of these things which is almost like an endless loop. It's something you just have to keep working on. So here's a basic checklist for performance. Are your patches current? Is your firmware current? Did you follow the memory plugin rules for the server? Do you have all your DIMMs filled? Make sure your OS is current. Have a look at the use of SMT8. Is it helping you? Is it something you should move to? Is it something that will hurt you? Make sure your shared LPARs are sized correctly. And never ever use cores for sizing. You should look at RPerfs and size that way. Look at your virtual processor to entitlement ratio. You do not want to have a 20:1 ratio where your entitlement's 1 and your VPs are 20, because you'll forever be growing and shrinking. And if it's a busy LPAR, you'll also always be above entitlement. Look at your Java levels. There are Java levels that you should not be running, and specifically Java 1.4 is known to perform poorly on all power systems from Power 7 and above. Make sure you're running the latest compilers, and if you're moving code that you've compiled between architectures, you should recompile it. There are a number of AIX restricted tunables, and I see people using them all the time. If you're going to use those, please make sure that you have a PMR open with IBM and that they have told you it's okay to use them. There's a reason why those tunables are restricted, and in fact it's highly likely that they will disappear in the future. You need to make sure you size your VIO servers and LPARs correctly, and I'll talk a little bit later about tuning your virtual Ethernets. As I mentioned earlier, one of the best ways to avoid problems is to stay current. The slide lists a number of things about Java, minimum levels, and so on that you should pay attention to. The reason that IBM has these in here is because while the earlier versions will work, they are known not to perform well. In fact, IBM has a very strong binary compatibility statement, but you'll never see the word performance in there. So anytime you have the opportunity to go to a newer level of a compiler or Java, or to recompile your code when you move to a new architecture, you should absolutely do that so that you don't run into these things called emulations and alignments, where code is no longer available, so what they do is they emulate that code. And that slows you down. Also be aware that as you move to Power 9 and Power 10, there are minimum HMC requirements. And in fact, for Power 9, it's HMC 9.1 modification level 940. As you move on, you'll find that you'll go to firmware 950 and 951, but be aware that those only run on specific models of the HMC, and they do not support servers prior to Power 7 Plus. Version 8 is no longer supported, so you have to be on version 9 anyway. So this is the time when you should be looking at your HMCs and seriously considering replacing any of the old Intel HMCs, which will not run the new levels of the HMC software. You should be replacing those with the new Power HMCs, which are a 7063 CR1 or CR2. Keep in mind that not all workloads are going to run well in the shared processor pool. There are certain types of workloads that are latency sensitive that are better to run dedicated, so you may have to do some performance tests with those. And then our 7th tip is all about providing resources. We're talking entitlement, virtual processors, memory, some things around disk settings, and then some network settings as well. So let's start with some general server sizing thoughts. You want to make sure you have enough processor power and that you balance everything around. You also need to understand the difference between minimum, desired and maximum, and their effect on system overhead. As an example, with memory, the overhead for memory settings is actually based on the maximum setting, not the desired. That's because every LPAR has to have translation control entries for its page tables. So what they do is they take that maximum setting and divide that up by the LMB and do some other math, and they reserve that amount of system memory to do the real to virtual mappings for each LPAR. If you set your maximum settings too high, that can be significant. You should also look at where you're going to use shared or dedicated processors, where they're going to be capped or uncapped, and if they're not capped, then you need to look at the number of virtual processors. Never ever starve your VIO servers or your client LPARs. And also be very cautious about sizing studies. One of the things I found with sizing studies is that they tend to undersize memory and quite often the cores, because they forget about the fact that you also need to size that server to include what your VIO server will need. And one of the last things I want to mention has to do with scaling and sizing. When you're comparing boxes, you need to scale by RPerf or some other benchmark data, not gigahertz, because gigahertz in many ways is fairly meaningless, because RPerf is about how much throughput you can get, and all of the power servers are throughput-based machines. Also, do not size the box by the sum of the entitlements. I see this all the time where people have, 20, 30 LPARs, and they basically, if you sum up the entitlements, every core is in use. What that means is that your LPARs can't shrink and grow, because the whole idea is that you set the entitlement to what you're using, a little bit above average, and then you have your VPs set to what you're going to peak at. Well, if all your LPARs peak at the same time and you size the box by entitlements, then you're not going to be able to grow and shrink, and you're going to have a lot of latent demand and some serious performance issues. So that's what I'm getting at here, where I say don't sum the entitlements. If you look at this system here, I have 4 LPARs, and I have the number of cores that I need, and they sum the entitlements, so they thought they needed 11 cores, but actually when you look at how they peak at noon, they actually really need 21 cores. Make sure that you understand how your workloads work. By default, there are some tunables that should be set on your system that are not set automatically. They are specifically the network tunables for RFC 1323 and TCP send and receive and UDP send and receive. And I have minimum levels here, but you should always tune those, because by default they are not tuned, and you have UDP traffic in your system even though you think you don't, because that's what things like the domain name servers, etc. use. I also tune my HBAs, and this is sort of a starting point that I use. You can go above 1024 if your disk subsystem supports it, and if your VIO server is set to at least that high. In order to set any of these fiber adapter settings, you must set them on your VIO server and reboot your VIO server first. If you don't do that and the LPAR ends up coming up with a higher value, the LPAR won't boot. I also tune virtual buffers on my LPARs and on my VIO servers to make sure that I have enough tiny, small, medium, etc. buffers. So this is the default that I would use, where ENT4 and ENT5 are virtuals. You would need to check it individually for each of your systems. And you don't need to tune them on every system, just ones that have a lot of network traffic. In terms of the HBAs, I already mentioned this, but I actually make tuning changes on all of my LPARs and on my VIOs. There's also a max transfer size. The default is a 16 meg DMA. It turns out that under the covers at one of the levels they actually give you one anyway, but I always set it to a 128 meg DMA, and then depending on the adapter type you can sometimes check it high. You can change it to a higher value, which is the line that's 0x10 00000, and depending on the bus type you may get a 256 meg DMA or you may get 128 meg. This can make a significant performance change if you're running really, really large IOs. So I very rarely change it beyond the 128 meg DMA. And again, this is one where the VIOs must be booted with a setting the same or higher. So the next couple of sections I'm going to talk a little bit about CPU and memory. And we're going to start with entitlement and VPs. In Power 5, 6, 7 and 8 and Power 9, they use different utilization calculations for CPU. The VPs get unfolded sooner. From Power 7 and above, it's actually at lower utilization levels than it was on previous systems, which means that you may see some high virtual context switches in LPAR stat, which tells you that you need to pay attention to your virtual processors. So starting with Power 7, you may see cores activated at lower utilization levels, but you'll see higher idle. And what they did was they basically changed things so that prior to Power 7, it would activate the first SMT thread on a virtual processor, then the second one, then the last two, then it would activate a virtual processor. But with Power 7 and above, what it does is it activates the primary thread on the first virtual processor, then on the next VP it activates the primary thread, etc., until all the VPs are used, and then it goes back and does the secondary threads and the tertiary threads. So just be aware of that. If you only are using SMT primary threads, you probably have too many virtual processors. So you can avoid this by reducing your VP counts, by using realistic entitlement to VP ratios, and the recommendation that I got from Nigel was that you sit around 0.6 to 0.7 of the VPs, so there's some numbers here that you can look at that you can use as starting points. We already talked about not letting workloads run above entitlement. And be aware that on your VIO servers, that entitlement is critical because it really impacts your SCAs. And the reason we're concerned about virtual processors is that every virtual processor has to be dispatched before one can be redispatched. So as an example, what I see sometimes is I'll see a shared processor pool, and let's say there's 20 cores on the server. They'll allocate 22 cores to the shared processor pool, which you shouldn't be able to do, or they'll give an LPAR more VPs than there are physical processors in the server or processors in the pool. So now all 22 of those have to be dispatched before you can go back and dispatch the first one, but you only have 20 cores to dispatch across. So just be aware that you really need to understand those things, because it will absolutely degrade your performance, because there will always be, in this particular case where I have 20 cores and 22 VPs, I'm always going to have 2 VPs waiting to be dispatched. Now, after you do an upgrade between technologies, you really should review your VPs and entitlements, particularly if you've got large LPARs. Depending on the architecture, you may have more threads and you may have more, well, you'll definitely have more RPerf per core. So something that might have needed 16 cores on one technology only is going to need maybe 12 on another technology. So that's something that you want to look at, is use your RPerf numbers to get an idea of relative performance and figure out what you really need after you do the migration and do some resizing. If you have too many cores or too many VPs, you're just going to waste dispatcher and hypervisor cycles. Now, with that said, if the LPAR with 16 cores is like running at 100%, then you have latent demand, so any resizing you probably should do after you migrate it, after you've had an opportunity to measure what it's now using. And this is just an example to show you what NMON would show for an LPAR that is actually running pretty much consistently above entitlement. You'll see that it's got 16 VPs, it has an entitlement of 10, and it's running somewhere between 12 and 14 most of the time. So this was affecting both its CPU performance and also its network performance. I mentioned earlier that LPARs can be capped or uncapped. If a capped LPAR is running, it can give unused cycles back and make them available for others, but it can never grow beyond what its entitlement is. An uncapped LPAR can go above its entitlement up to the size of the pool or the total desired virtual processors, whichever is smaller. And of course, unused capacity is always seeded back. So When you have a competition for CPU, two LPARs are requesting, let's say, 2 cores each or 3 cores each, and there's only 3 cores available. What happens is it looks at the weight for each of those LPARs and it sums them. So in the example I've got here is if LPAR A has 100 and B is 200, then the sum is 300, and then we use ratios. So A would get 1/3 of the available core and B would get 2/3 of the available core. So when you're planning your weights, you need to use common sense and make sure that things are put in the correct place. So as an example, for my production VIOs, I'll use 192, or quite often I use 255. It makes them the most loved ones. Maybe I'll set production at 160 and test development at 128. Essentially, you need to have a plan. It doesn't have to be one, but you need to know when an LPAR is added, what should the LPAR be set to for a weight if it's going to be a shared LPAR that is uncapped. Now, there are multiple ways you can cap an LPAR. You can set it to capped. You can set its LPAR weight to 0, which is what we call a soft cap, or you can set the desired virtual processors to the same as the entitlement. Those are the 3 ways you can cap an LPAR. The maximum settings have nothing to do with capping. When I set max VPs, that just means that that's the maximum number of virtual processors I can grow to by using a dlpar command, and the same applies to max CPU. And capping and pools are used quite often to ensure that licenses are adhered to. So you should actually pay attention to those and make sure that you're not exceeding the licenses that you have. I had mentioned earlier that not all applications benefit from shared processor LPARs. And below is sort of a list of the kind of things you have to watch out for. I ran into this with a trading application, which is very, very latency sensitive. It had to have dedicated cores because it could not wait to be dispatched. And the issue with shared processor LPARs is that you are not necessarily dispatched to the same core each time, and you may get dispatched to a core that's on a different node. It just depends. So while it's very, very fast, there are some delays that are built into shared processor LPARs. However, they are absolutely perfect for Oracle databases and our typical OLTP web applications and mail servers. There's very few times when you really have to have dedicated LPARs, but they tend to be very long-running applications like SAS, or applications with polling behavior or that cannot handle any kind of a latency delay. So just be aware of that. I had mentioned earlier that we now dispatch all of the primary threads to every VP before we dispatch any of the secondaries or tertiaries. That's actually called raw throughput mode, and that was the change at Power 7. So IBM will actually dispatch all the virtual processors once a utilization of 49% gets exceeded. And then once all of the virtual processors are running primary threads, we go back and we use the second one. You can actually change this, but be very, very careful doing so. You really need to know what you're doing, because you can cause a very, very large thread performance degradation. So I typically leave the system running correctly in raw throughput mode. Now in Power 9, there was a session that Steve Nassipany gave at PTechU in 2018 where he talked about the fact that the virtual processor code was now aware of the core architecture, and so some of the smaller workloads will actually be collapsed a little bit more aggressively when their workloads were present. And this has the ability to reduce physical consumption. And by the way, one of the ways that you know you have too many VPs is if you're seeing all your physical cores being consumed, but you have very, very high idle time. So just be aware of that. So this is an example that you can see where all the primary threads are being used, but none of the secondaries. So we could probably cut back our cores or VPs. And in fact, we decided to cut them back to 16. This is an SMT8 example showing using the primary and secondaries, so we decided to leave this one alone. And this is an example with an LPAR stat where we have 20 virtual CPUs, 4 SMT threads, so altogether we'll have 80 logical CPUs. And this is a dedicated LPAR, but notice how it still refers to them as virtual CPUs. They are, however, dedicated. And this is an example of a shared processor pool LPAR. And what I'm showing you here is that you need to compare the virtual CPUs to the pool CPUs. And they need to be the same or less so that you don't run into an issue with virtual processors. So this is an example here where we had a pool with 17 cores, but our actual virtual processors were set to 18. So that meant that at all times there was one virtual processor that could not be dispatched. And here you look at virtual context switches, you see they're a bit on the high side. And so you want to basically go back and correct the number of cores that are allocated to the cell path. Also, if you want to see good values for things like the available physical processors, you need to go into the HMC and turn on the check mark for allow performance information collection. Otherwise, you can't do shared processor monitoring. And this is just an example for the same thing for a dedicated LPAR. And some examples in the next couple of slides for showing how things are broken down with MPstat-S. I've switched to using VMstat-I because it gives me a number of fields that I'm very interested in. The P column in particular if you're using raw devices, and the W column, which is the number of threads waiting for file system direct I/O or concurrent I/O. So there's a number of interesting things here. I already talked about shared processor pool monitoring, how you need to turn on allow performance information collection, and then there are a number of ways to actually monitor those pools. And that's what these slides are showing, what it would look like with a topaz-C or using the nmon-p flag. And then of course you have the nmon analyzer LPAR tab, which gives it to you in graph. I mentioned earlier alignments and emulations. You can tell if you have an issue with those using the emstat command, and that will check and see if you have got any emulations and alignments. They're typically caused when you're running old code and you brought the binary across and you're running it on a new architectural operating system. It's one of the reasons why Oracle tells you to relink all of their binaries whenever you switch architectures or you upgrade the operating system. It's to avoid these. And now we're going to move on and talk very quickly about memory. There are basically three different kinds of memory. There's the kernel, which is AIX itself. There's persistent memory, which is backed by file systems. And then there's working storage, which is the dynamic memory that includes executables, work areas, and that's backed by page space. Anytime we have to steal a page, it is much better to steal from persistent memory than it is from working storage, because working storage has to be copied out of page space, versus if we steal something that's backed by a file system, if it has not been updated, then we do not have to write it back out to the hard drive. One of the things that I mentioned down here is that if you're looking at a VMstat and you see that percent computational is getting close to 97%, then you're going to be paging, and the only real solution is more memory, or find out what application's causing it and fix it. All of the settings for min-perm, max-perm, max client, LAU file page and page steal method impact those decisions, but on an AIX 7 and higher system you should not be changing any of those anyway. The defaults should be sufficient and correct. If you are changing them, you should have a recommendation from IBM to do so. We do need to plan for the firmware overhead for adapters. When people calculate their memory needs, they forget about firmware overhead. You can use a system planning tool or you can use your own tool. I use a spreadsheet where I basically add in all my cards and how many active ports there are and figure out what the overhead is going to be. And don't underestimate it because it can be high. So if you look at your HMC scanner report and you look at each of your LPARs, you'll see there's a maximum memory setting. The reserved memory per LPAR for the hypervisor page tables is based, as I mentioned earlier, on that maximum memory setting. So if you look at this example where they've all got small amounts of memory but they have maximum set to 100 gig, the overhead on this LPAR is going to be very high. In an HMC scanner report, you can actually see that there is a firm GB line. That's actually the overhead on that server as of this point for memory. And there's several things that can impact that. As I said, it could be impacted by the I/O adapters and the number of them that are active. It can also be impacted if you have firmware memory mirroring turned on, and of course the maximum memory size. I mentioned paging before. You want to make sure that you have enough page spaces, that they're on different disks, and that they also are all the same size. You don't want to have different size page spaces, because if one fills up, it round robins amongst them. So it'll try to write to the one that's full, and then it will have to try to page to another one. So you just, not only are you paging, but you now slowed your paging down. Obviously the real thing that you want to do is avoid paging, but if you can't avoid it, then you want to make sure that you do everything you can to allow your paging to be fast. So we also do not put page spaces on busy disks. I typically allocate some 20 gig LUNs that are just dedicated for paging purposes. svmon is a very useful command for looking at your memory breakdown. It'll actually show you what your pinned memory is, and it'll also show you what you're using. And one of the reasons I look at pinned memory is because if that's high, somebody somewhere is pinning memory, and you may want to know why. Because if someone's pinning memory, it's not available to anybody else, and so that could be one of the things, if you're paging, that could be causing it. So the kind of things you do to look for problems, you run lssrad, mpstat, topaz, svmon. There's a number of different commands that you can use. So we start out by, we look at computational memory use. What's our AVM, right? That's basically how much memory do we have total. And that's what's going to show as percent computational. It's going to show as a percentage of memory. And like I said earlier, if it gets close to 97%, you have a problem. Then you can use various flavors of svmon to sort processes based on certain parameters. So you can say, tell me who's using most of the page space, tell me who's using most of the memory, etc. Affinity is something I want to touch on very quickly, because it is something that can affect you. I used to come from the mindset that I would only fill half the DIMMs in a server, so that when I had to add memory later on, I didn't have to worry about having to take memory out and put memory in. So that mindset's kind of gone away, because if you look at all the benchmark results, etc., that are published, they're based on every DIMM being filled. And it has to do with these things called SRADs and affinity. So typically there's three terms that we use: local, near, and far. Local is within the same chip, and it will show as S3. Near is within the same node, so we call that intranode, and that shows as S4, and far is on another node, or internode. So this is for the 880s and above. It's similar on single node systems, but it's not going to be as big an issue. So what we can run into is we could have chips that don't have any DIMMs. So over on the right you can see where it says empty. And what will happen is something will get dispatched, and if it's got no local memory, then it's going to have to go across to a core that has memory. It'll still run on the core that has no memory attached, but it's going to be accessing its memory from elsewhere. We try to avoid that. The hypervisor is smart enough to avoid activating cores without local memory, but obviously if it needs more memory, then it's going to go get it. So that can cause you a performance problem. And this is the example of an mpstat-d, and I've put in red where local, near, and far are. This is a multi-socket E850, so it was good to see that for the most part it was all 100%. And then here's an example for an E880, which is a multi-node system, and the good news is I saw nothing in S5, so there was nothing that was going to a separate node. It was all within the node. It was just going across sockets. Now when I look at a vmstat-v, the things that I'm looking for are pending disk IOs, page space IOs, external page or file system IOs. These are the things that are telling me that my IOs are getting blocked. In this case, the P buffs are where it goes and it builds the IO requests. Then it looks at that IO request and determines, is this a page space IO, in which case it'll try and get a page space buffer. Is it a JFS IO, in which case it'll try and get an FS buff. Or is it a JFS2 IO, in which case it'll get an external pager file system buffer, and so on. As you can see, this system was not in good shape. Now these are recordings since boot, however this system had not been booted that long ago, so these numbers are very high. And these things build up on themselves. If you don't have enough pbuffs, then you're going to, if you don't have enough page space buffers, then you're going to end up backing up into the pbuffs and so on. So just be aware of that. This is a slightly healthier system. It just basically had a paging problem, and you could see that it was using 89.9% of computational. So this was one where most likely adding a page space would have helped, but also adding some memory. And the only way to fix that page space buffer shortage, you can either add an additional page space, or you can swap off a page space and then make it bigger. But the problem with doing that, of course, is you want all your page spaces to be the same size, and if you're already paging, if you swap off a page space, it could have a very nasty result. So just be aware of that. The other thing to look at is memory pools in the free column. A lot of people don't realize that the min-free and max-free apply per pool. So if you have max-free of 2000 and you have 10 memory pools, then it's expecting that you're going to have 20,000 free pages. Otherwise it will be doing some page stealing or page thrashing. With min-free set to 960, in this particular case we're going to be page stealing because max-free was set to 1088, so we were between 960 and 1088. We only had 990 pages free per pool, and that put us in a situation where we were going to page steal until we could steal our way back up to where we had 1080 per pool. So just be aware that you need to pay attention to the number of pools, which you can tell from a vmstat-v, as well as the free column. You may think you have enough free memory, but you may not. So I typically do a calculation for min-free and max-free. I'm not going to go into it here, but I typically will see what my values are set to, and then I will modify max-free and min-free as needed, just to give myself a little gap and to buy myself a bit more time if I do have a problem. And then one of the things I want to touch on is nmon. I use nmon all the time. I actually run at 724, and this is typically what I would do if I was using a 30-minute nmon just to grab a quick piece of performance data. If I want a 24-hour one, I take a snap every 150 seconds, and I do 576 of them, and that happens to cover 24 hours. But figure out what works for you and what the intervals need to be for you. But those nmon reports can be very useful, and if you're running them all the time, it allows you to go back and see what happened yesterday and so on when people start asking you questions. I found this PDF at the IBM website, and it has a nice little checklist of things that you should look at in terms of keeping your Power 9s performing well. So I wanted to include that in here. So my 8th tip is that you should use NTP. There is nothing worse than trying to debug a performance problem where every LPAR that's in the middle of the mix and your VIO servers are all showing a slightly different time. It also will help you with LPM. So I definitely set up NTP or some kind of time service to make sure that all my LPARs and VIO servers are correctly synced for time. And then I've mentioned a couple of times updating your IO firmware. After you've done your HMC and your server, since most of the IO is attached to the VIO, I just integrate this as part of my VIO update. And I run LSM code, I go download the correct adapter code, you use the RPM IVH to actually have it downloaded into the Etsy microcode. And it's not till you run the diag-t download that it actually installs it. Now if you're working on your SEAs, you may have to turn those off, so I'll show you how to do that in a minute. I usually, if I'm working on my primary VIO, I'll flip it into standby mode, so I force a failover, and when I'm done I bring it back to auto mode. That way I know immediately before I start updating anything if there's an issue with my network setup. So to unconfigure that SEA, you can IF config it down and detach it, and then rmdev-allit. And then when you're done, You can just run config manager and it'll come back, check with SMTY, TCP IP, etc. The one thing I would suggest is that ahead of time that you document what all your IP settings are, just in case it doesn't come back right. And then the last thing that I have in my recommendations is not using restricted tunables unless IBM support tells you to. This is really, really important, because if you have a performance problem, and you may have caused it yourself by using restricted tunables. So I want to thank you for listening to this session, and I hope that you found it useful. Feel free to reach out to me. I also have a copy of the presentation uploaded at my website if you can't get to it from the PTechU sessions. And please fill out the survey. We do look at all of the evaluations. Thank you and have a great day.